Question: do we follow on the Google Docs? Do we follow the PowerPoint while you're doing this, or
Yes,
no?
I posted that
Okay.
on Google Classroom. You can access it if you like. If you're at home, you're welcome to just print that out or whip out a piece of paper. You do you. All right, so this is the first lesson in the last unit in grade 10 science, and that is climate change. This is an introduction to climate in general. So we're not really going to dive straight into climate change. There are many lessons that we need to learn before that. So basically today, it's just what is climate? What are the factors that affect climate on Earth and the different spheres and what they do? Okay, so moving on. First of all, the word climate is different from weather. Okay, you whip out your phone, you can check today's weather. Weather refers to short-term weather, for a lack of a better word. Short-term temperature, precipitation, pressure, those are weather. But climate is long-term. It is the average of the weather over eons, okay? Thousands of years, hundreds of thousands of years. And different places on Earth have different climates. And in the picture, you can see 4 very different climates from all across the globe. So in the past, the climate was different. So if you can stay in the same location, the climate will change over time. So the Ice Age, which occurred about 20,000 years ago, if you live in North America, specifically up, say, Toronto, yeah, you'd be under like many kilometers of ice. Okay, so the climate has changed and it is continually changing. And in this graph, you can see that throughout history, up to like around 450,000 years ago, you can see the temperature, the average temperature of the planet going up and down in a cycle. You have these peaks in temperature, and today on the right is at one of those peaks. That means we're in a warm interglacial period. The valleys means the average temperature was, they were a lot lower. So those are the ice ages. If you look at the map of the world today, you notice that North America is not connected to Asia. It is very close. If you look at Alaska and Russia, they're really close together, but it is not connected. That is because the ice had melted. So during the ice ages, like 100,000, around 10,000 years ago, in this picture, wait, where's my picture? There it is. In this picture, the Bering Strait, the channel between Russia and Alaska, it was frozen. So humans literally walked over into North America. Okay, so humans originated from Africa. There's no way to get to the Americas. Humans can't swim, and a few 100,000 years ago we had no technology, so you just had to walk. And this land bridge, because of an ice age, enabled humans to walk across, and hence we see people in North and South America today. So what causes these climate cycles? Because climates, they usually occur in cycles. Right now it's warm. We're on track to become warmer, but eventually in the distant future, we're going to have another ice age. So what causes these? Well, the cause is due to something called Malakovitch cycles. Okay, what is Malakovitch cycles? Well, if you look at the picture, the climate of the Earth depends on many factors, and one of those is the orientation of our planet with respect to the sun. As you know, our orbit is elliptical around the sun. So look at the first picture. We don't actually orbit the sun in a perfect circle. Now, in the picture, it is greatly exaggerated. It is nowhere near that elliptical. It is almost a perfect circle. But alas, it is not. And the eccentricity, how flat that oval is, it changes over time. Okay, so that accounts for part of the reason of a shifting climate. If you have a more eccentric orbit, you stray further from the sun, you have a colder climate at that time. But again, this is insignificant because the eccentricity is very, very low. It is almost perfectly circular. And another reason is that the Earth axis is tilted. You've learned in grade 9, and that is the cause of the seasons, okay? The axial tilt of our planet. And today, the tilt is about 23 degrees on its side, but then this is not constant. It kind of wobbles. This degree, this angle, it varies between 22 and 24.5 over the course of tens of thousands of years. So right now, it just so happens to be 23, and that is currently changing. Very slowly, but changing. And as you know, the more tilted the planet is, the more extreme the seasons become. If you have an axial tilt of 0, that means you're upright, you're like 90 degrees. That means you don't experience seasons. Okay, it is the tilt that causes the variations in the temperature in different seasons. And so that also changes. How cold winters are, how hot summers are, that is dependent upon the axial tilt. That changes over time. And then lastly, there's something called precession. It is the last picture, the last planet to the right. The Earth axis, it wobbles in a circle. It's just like a spinning top. If you spin a top, it will spin initially. As it slows down, it's going to start to wobble. And this wobble also changes the climate. So the Earth is wobbling over a slow cycle over the course of around 20,000 years. This is called precession. All of these combined together account for the different climate cycles. Okay, the ice ages, the interglacial warmer periods, they're all a combination of these three factors. So
I have a question.
yes.
If you go back one side on the tilt, is the tilt in relation to the sun, or how do you measure the tilt?
Yes, it is in relation to the plane that the planets orbit the sun.
Okay, but if there's like no up or down in sun and the Earth is spherical, how do we really know that it's tilted at that angle?
Oh, okay, that's a good question. So you know how the Earth and all the other planets orbit the sun in the same plane. Okay, it's a flat disk. All the orbits account for a flat disk. And if you just imagine the sun in the center and a big flat disk around the sun, kind of like Saturn's rings, we are on one of the orbits going around the sun. And how do we account for the axis? Well, the axis is, the axle that the Earth spins, rotates around, and that, with accordance to the disk, it's not 90 degrees. If it is, then we have no tilt. Okay, it is slanted by an angle of 23 degrees. Does that make sense?
Yes, that makes sense. Thank you.
Okay. It's better to have a picture. Unfortunately, this medium does not allow me to draw you a picture. So you just have to use your imagination. I'm going to move on. If you still have a question, again, stop me. Okay, so here's a picture. You see what I mean? Here's the sun, and there's an orbit. The Earth axis, the axis in which the Earth rotates, it is not perpendicular to the flat disk that we orbit the sun in. So right now, our axial tilt is 23 degrees. If you actually stand on the North Pole and you look directly up, you will see a star. That star is Polaris. Okay, we call it the northern star. It's called the northern star because it is exactly on the North Pole. All the stars in the night sky, it will seem to rotate around that star throughout the night because the Earth is rotating. Our view of the sky, therefore, also rotates. But Polaris does not change because we rotate on the axis, and the axis points to it. Now, in 13,000 years, precession would have moved the Earth axis all the way to the other side. It will no longer point at Polaris, it will point at a different star, Vega. So that will be our new northern star in 13,000 years. That doesn't concern us today. Today it is Polaris. Now, these things in conjunction with the axial tilt and the eccentricity of the orbit, it changes the amount of energy we receive from the sun. Even a slight change will cause a huge change in climate. Right? So that's Malakovitch cycles. That's what causes the different climates in Earth's history. Now, what else accounts for the climate? Oh, yeah, I screwed up the PowerPoint, and this is going on YouTube. Never mind that. Another thing that affects the climate is your latitude. Depends on where you live on the planet. It almost is common sense. Most people are from the northern hemisphere, and we are in the northern hemisphere, so I'm just gonna use the northern hemisphere as my assumption. So the more north you go, the colder the climate, because the closer you are to the North Pole. Now, why is that? The reason is in the picture. It has to do with Earth axial tilt. The Earth is tilted at 23 degrees. In the summertime, it is tilted towards the sun, but in the other hemisphere, let's say summer in the northern hemisphere, it's winter in the south because it would be tilted away. And look at the light rays. The light rays spread out over a larger area the more north or more south you go. If you just look at the North Pole, the same amount of light rays is spread out over a much greater area than near the equator. So you have less sunlight per area, meaning that you have less heat. So you're cold. Okay, so this is the reason why when you approach the poles, north or south, the temperature gets cooler. And as you approach the equator, the temperature gets really hot. Okay, does that make sense? If you don't have any questions, I will just move on. Okay. Yeah, I missed that one. All right, so the Earth's climate system, the climate system on Earth encompasses many different little systems. So the climate system has 4 separate components. You would have the 4 spheres: the atmosphere, the hydrosphere, the lithosphere, and the biosphere. So we're going to learn every single one of these. Atmosphere is all the gas around the Earth. Hydrosphere is all the water in the lakes, the oceans, the vapor in the air. The lithosphere is all the rocks, the crust, the land. And finally, biosphere, everything that is living on Earth. So they all affect the climate in their own unique ways. So starting with the atmosphere. Now, the atmosphere of the Earth is very, very thin. You might be thinking, wait, it doesn't seem thin. If you hop on an airplane, it will take off, and when you're in the sky, you look down, you're still in the atmosphere. And if you jump off the plane, that is a long way to fall. So it doesn't seem to us like the atmosphere is very thin, but compared to the size of the Earth, it is ridiculously thin. It is like you take an apple or a tomato or some kind of fruit, you peel off the skin. Okay, don't take an orange, take a fruit with really, really narrow skin like apples and tomatoes. That is your atmosphere. And the component of the atmosphere, we've learned this, I believe, in grade 9, mostly nitrogen, 78%. That is completely useless because we can't metabolize nitrogen gas. We need to convert it into a different form. 21% precious, nutritious oxygen. Okay, we need that 21% to survive. And then 1% of everything else. You have traces of argon, carbon dioxide, helium, hydrogen, unfortunately, ozone near the ground. So all of these encompasses the air. So basically, mostly nitrogen, the rest of it, oxygen, very minuscule amounts of other. So the atmosphere is not uniformly distributed. The closer you are to Earth, the more air there is because of gravity. We live near the surface. Okay, so we live in something called the troposphere. So the atmosphere is subdivided into different sections. The one closest to the surface is the troposphere. Even if you climb to the summit of Mount Everest, you're still in the troposphere, although the air pressure decreases drastically. Higher up, you have stratosphere, and then higher still, mesosphere, and then thermosphere, and then you're no longer in the atmosphere, you're in the exosphere. Okay, so most of the air is in the troposphere, around like 90%. The atmosphere not only provides us with air to breathe, but also it blocks dangerous radiation from the sun. So in physics, we learn that light is actually composed of many different wavelengths and energies, and the sun emits all of them. We typically don't have high energy radiation near the surface because the atmosphere will block that. Okay, specifically, the ozone in the stratosphere, it will block gamma rays, X-rays, and ultraviolet. What mostly reaches the surface is visible light, which is why our eyes evolved to see visible light, because it is the most abundant light that we receive from the sun. We don't have all of the light. Now, if the ozone were to disappear, we have a huge problem. Then you have X-rays and ultraviolet rays outside. If you walk outside, you're taking a huge risk because you can get cancer. All right, so the greenhouse effect is a really important concept in this unit. We're going to slowly build up to that, but here is a rudimentary look at the greenhouse effect. So basically, the greenhouse effect is gas in the air trapping heat, warming the planet. If we were to remove all the air, Earth will be a lot colder. Okay, so we are warm, relatively speaking, because not only does the sun hit the ground, it is absorbed by the ground, radiated again, and trapped by the heat. So that's why it has a warming effect. Okay, so the more greenhouse gas you have, the warmer your planet. And this is supposed to be a good thing, because without it, we will all freeze to death. The average temperature will be like minus 15 degrees on Earth. I'm talking about the average. That's bad. Right now, with the greenhouse effect accounted for, it is around like positive 15. Okay, so moving on to the hydrosphere. So that's enough about the atmosphere.
I have a question.
Yes.
Sorry. If you go back 2 slides when you were looking at the kind of the chart thingy, up there it says in the thermosphere, it says temperatures increases to 2,000 degrees. How does that happen?
Oh, I wouldn't worry about details like that. I'm not actually gonna care about the temperature in the different layers.
Oh, okay. Never mind then. Thank you.
All right. Okay, anyway, hydrosphere, all the water on the Earth. Now, water also absorbs energy from the sun, and water can heat up as a result, and then it will release energy back again. So these interactions will affect the climate. So here's an example. If you have a lake and the sun shines on the lake will absorb a lot of that heat. And because water has a really high specific heat capacity, it takes a lot of energy to heat up the water. And as a result, this cools the surrounding. So that's why if you live near a lake in the summer, it's not as hot as, let's say, somewhere dry for everything else, if everything else is kept constant. Okay, so if energy is being used to evaporate the water, it is not used to heat the air. So we take energy from the air to evaporate water, cooling the surrounding. The opposite is also true. Okay, if you don't have water, you won't have this effect. So your summers are relatively warmer than, let's say, near a lake. Does that make sense? No questions. Okay. Similarly, if, let's say, water condenses, so the opposite occurs when it gets cold, water will condense. This releases heat. So this has a warming effect in autumn and winter. So living near water is supposed to give you better summers and winters, if you will. Cooler summers, warmer winters. That's a beneficial effect. Now, if that freezes, you get ice. And ice and water, they have different properties. There's something called albedo. That is a measure of how much light is reflected by any surface. If you walk outside on a cold winter day in Canada, there's probably going to be snow. And if the sun is up, you probably want to wear sunglasses. It's going to be bright everywhere. This is because snow is a great reflector of light. A lot of light bounces off of that snow into your eyes. So that's why it seems so bright. Now, if you walk outside on a warm day where there is no snow, like the ground is brown, the pavement is gray, water is blue, those things, they don't have high albedos, so they don't reflect a lot of light. So how much light you reflect also affects the climate. If you reflect a lot of light, let's say ice or snow, well, the light is not being used to heat up your environment. It's being bounced right back. That means it's cooler. So ice and snow has a cooling effect. Rocks, soil, those darker objects, they have a warming effect because they absorb the heat. They don't reflect a lot back. Okay, so those also affect the climate. So moving on to lithosphere, which is what we were talking about, rocks. Yeah, rocks have low albedo. They absorb a lot of heat, having a warmer effect. So basically the same thing I said. Here is the PowerPoint that goes with it. Now, how this works is sunlight hits the ground. The ground absorbs that sunlight, and that light loses energy to become infrared. Okay, visible light has higher energy than infrared, as we learned in physics. And then the ground will emit that energy again. And this is a warming effect. So the ground is warm because it emits absorbed light. Okay, and another effect is if you have a mountain, it depends on where you live, on which side of the mountain you have drastically different climates. In Canada, this is observed in British Columbia and Alberta. British Columbia, as you know, has really tall mountains, the Western Cordillera. And BC has a lot of rain. If you go to Vancouver, it rains a lot because this is the windward side of the mountain range. The ocean will carry the moisture up the mountain and it will descend as precipitation. That's why British Columbia has a lot of rain. It has rainforests, so lots of tall trees there. Unfortunately for Alberta, which is right beside British Columbia, it is very dry. You don't see a lot of trees in Alberta. It is called the prairies. Okay, in the prairies, everything's flat, not a lot of trees. You have little grass and little shrubs. Those are great land to farm on, but you don't get a lot of rain because the mountain blocks the rain, and BC gets it, but on the leeward side of the mountain, it is relatively dry. So we call this the rain shadow effect. So this explains the climate of British Columbia and Alberta. All has to do with that mountain. Okay, and lastly, you have the biosphere. The biosphere includes everything living, plant, animals, bacteria, and the other microorganisms. We metabolize energy, and this can also affect the climate. So basically, plants, they absorb carbon dioxide, they convert that into oxygen, they use the carbon to make sugar so that they can build their bodies, and they exhale oxygen back into the air. So they reduce the amount of carbon dioxide in the air. But carbon dioxide is a greenhouse gas. It has a warming effect. So trees have a cooling effect on the environment. It takes CO2 away from the air. Okay, that is a natural process through photosynthesis. Now, animals, we do the exact opposite. We breathe oxygen and we exhale carbon dioxide. And this increases the amount of carbon dioxide in the air. We do it through the process of cellular respiration. So animals, bacteria that produce methane, all of these are greenhouse gases. They warm up the atmosphere, thus warming up the climate. Okay. Also, it works in reverse. If you cut down trees, if you burn forests, you lose plants that are able to take carbon dioxide away from the air. Okay, so that also has a warming effect. It's double bad. Now that you burn the trees, the carbon stored in the trees are now released into the air. So think about the Australian fire. So that has terrible consequences on the ecosystem. All right. This should conclude the lesson. So basically, we learned about weather and climate. We learned the various factors that affect climate, Malakovitch cycles, how Earth receives energy from the sun, how latitude affects climate, and the 4 spheres. This is a relatively short class, so any questions? This is fast.
Yes.
There are a few questions. Please ask. Yes.
I have a question.
Yes.
So, when you're talking about how animals, let's say, will heat up the Earth and plants will cool it down, essentially, was there any specific evolution that led to that? Like, did we evolve for that purpose, or is that just something that happened?
Oh, okay. Yeah. Are you referring to specifically the effect on climate, or you're asking how this came to be in the first place?
How this came to be in the first place.
Oh, okay. So this is not an accident. If you look into Earth history, in the beginning, the Earth is overwhelmed with carbon dioxide, and we have 0 oxygen, because oxygen is very unstable. It is very reactive. It will react with other gases to make something else. So if you look in the solar system, no other planets have oxygen except Earth. Scientists, astronomers, they look for oxygen as an indicator for signs of life, because life produces oxygen. Now, what happened in Earth history was you have a lot of carbon dioxide. So microorganisms evolved the ability to metabolize carbon dioxide. So those are the cyanobacteria. They can produce oxygen by absorbing carbon dioxide via photosynthesis. Now, as of now, all life are anaerobic. You can't have oxygen because there are none. Slowly, they accumulate oxygen in the air. Later, aerobic life developed. Okay, so we are aerobic life. We are what came after. So we have the plants and the bacteria to thank for basically creating oxygen from carbon dioxide. Does that make sense? Now, the cooling and warming effects of it is very minuscule. Over the long course of history, it has a significant effect, but for everyday purposes, you breathing you're not really contributing to climate change. Okay, there are other bigger contributors, but like, yeah, we shouldn't breathe less often. Does that make sense? Any other
That makes sense. Thank you.
I have a question.
Mm-hmm.
Could you go to the like the mountain thing, the mountain slide?
Which slide?
The one about the mountain and the rain.
I can't hear you. You have to speak up.
The mountain slide.
The mountain slide. So, wait, I missed this one, right?
The one after that.
This one. Okay.
Yeah. So, the ocean's pushing the moisture up the mountain, and so that's like rain. What
exactly?
Side is
that's
that?
The wind, not the ocean.
Oh.
The wind carries the moisture from the ocean up the mountain.
Okay, so on the other side, is it rain or snow or hail?
The other side, you don't get a lot of precipitation because the mountain will block the clouds in the rain. It will have a rain shadow effect.
But aren't there rainforests on the other side, or is that?
No, there isn't. Actually, the other side will be Alberta. We don't have rainforests in Alberta. We only have it in BC.
I have a related question. It's kind of stupid, but you know how the wind goes from the ocean all the way up the mountain? Wouldn't it push the clouds to the other side?
Wouldn't it push the cloud to the other side?
Like, you know, the wind pushing the clouds to the other side.
I mean, yes, obviously there are clouds on the other side. It's just compared to the side with the wind, there are less clouds. It's not like Alberta never rains. It does. Otherwise, we have a different problem. You see what I mean? Relatively speaking, Alberta has a lot less rain compared to BC. Does that answer the question?
Yes, thank you.
Okay. Any other questions, folks? If not, you still have homework, unfortunately. I have posted all of them on Google Classroom, so each handout, each lesson has a homework handouts that come with it. Please make sure you complete it. I will be checking when we go back to school, hopefully on the 6th of April. And did I post the assignment? I think I did, right?
Hopefully.
On Google Classroom. Please make sure you're checking. I posted basically everything to the end of this course, including your final project.
Oh, Mr. Zhou?
Yes.
Are we going to be able to do stuff like tests?
Oh,
swimming pool.
As of now, no, because we will be back at school on April the 6th. Well, at least that's the plan. So we're not going to have a test before that because we won't be finished with the unit. So no, you're not having a test yet. Okay. Now, knock on wood, if this lockdown extends beyond the 6th, then we're going to have to come up with a way of doing the test online.
Mr. Zhou, like what about the people who didn't write the physics test yet?
Oh, yeah, you're in Ukraine. Yeah, you're going to have to write it when you come back.
Like, do you think we're going to come back soon? Because like, I'm sure it's not going to be on April 6th.
See, I'm not sure. It depends on who you ask. If you read the news, a lot of experts say that we need months of lockdown.
Yeah.
I don't know if the government actually plans on doing that. I don't know if the economy can take that. So we might go back to school on the 6th. If this thing doesn't get better by then, yeah, the ministry might lock us down even longer. So then we'll talk, because we will have bigger problems. Like, how are you going to write your exams? How are you going to present your IRPs? So those are big problems. But we always will find a way to solve it. If not, I'll just email you the tests and you just do it. Like, that's the final option. Okay. So I wouldn't worry about you completing the test or the course for that matter. Anything else?
But there are some people outside of Canada right now. How are they going to get back? Because isn't there like a travel ban?
Yeah, there's a travel restriction. Okay, so if you're not a Canadian citizen, which I'm guessing a lot of you aren't, then yeah, you can't come back right now. So you're going to have to miss class, unfortunately. Again, we're hoping that this blows over soon. Hopefully by the end of the 2 weeks, the cases start to go down, and then we can try to relax the regulation. Although I don't think that, honestly, if you ask me, I don't think we're going back on the 6th. We probably shouldn't go back on the 6th, but we'll see. Yeah, if you can't come back, online lesson will be the thing you have to do. Yeah, so wait, wherever you are, stay safe.
If the travel ban does last, if the quarantine does last longer than April 6th, how will we do our exam? Is that just going to be like online or?
Yeah, we didn't discuss that yet because we didn't really entertain this possibility. We will have a meeting, all the teachers and staff tomorrow, and that could be one of the topics that pop up. Yeah, right now I can't tell you.
Oh, Mr. Zhao.
Mm-hmm.
Are the other lessons gonna be like longer? Because like right now it's only like what? Like
I'm sorry,
are the usual lessons gonna be a bit more longer?
Yeah, this is an introduction lesson, so it's not nearly as long.
Yeah, because usually
the other lessons, some of them are longer, some of them are just as short. Again, climate change is a short unit. There aren't that many concepts compared to biochem and physics, so naturally it is shorter. And judging from the state of our lessons, this is a good thing. You don't want to be learning a lot online. Any other questions, folks? All right, if not, then this should conclude the class. I will be posting this so you can access it and go over the slides again. Please make sure that you stay on top of your work. This is not a 2-week holiday. You have 3 subjects. This is not the only class you have to pay attention in. So make sure you keep yourself afloat by studying. And hopefully when we come back, there wouldn't be hiccups, because when we do come back, I won't have time to teach this again. Okay, these are actual lessons. You just straight up get the test. And then we'll end.
General question.
Mm-hmm.
So like, if you get work and a teacher says, due at the end of the day, do they mean by midnight? Just in general.
Yes.
Wait, what? Okay. What was the question?
Hopefully. Probably.
If you get work from a teacher and they say due at the end of the day, do they generally mean by midnight?
I would think it's the end of the school day, unless they specify it's midnight.
Oh, damn.
It depends. No. Like, you might have to confirm with said teacher.
Oh, okay. Well, thank you.
I have a question. So we don't have a presentation tomorrow, right? It's only Monday, Wednesday, Friday?
No. The reason for that is tomorrow, Tuesdays and Thursdays, I'm anticipating that some of you might have questions for me, although that is unlikely right now. We have 1 lesson and you've asked your questions, but my other students might have questions. So if you do, just email me, write to me in Google Classroom. I will post a separate video on YouTube, and then I'll link you to that video answering your questions. And online learning is not as effective as in-class learning. So I'm giving you more time to digest the materials and read your textbook. Okay, I know I haven't been using the textbook all that much because of the notes, but if you want more information, use your textbooks, okay, in addition to my notes.
We have textbooks.
Yeah, this is
wait. Is there an
I don't remember getting a textbook or anything.
No. We don't hand you the textbook. You have to order them.
Yeah, okay.
Tim, you're echoing so bad. Holy. Yeah, Tim, what's wrong with your mic?
It's the blue one, you know, the big thick blue one. It says
no, well, like, doesn't matter. It's fine.
Wait, Mr. Zhao? Is there like an online textbook? Because I know some teachers will like throw the online one on their website. And maybe
see, that's illegal. You can't distribute textbooks online.
Okay, well, when has that ever stopped anybody?
We're online.
You know,
True.
You know, unfortunately,
YouTube, you know?
I don't have my textbook.
Well, if you don't
That
have
was
a
your
textbook,
mic.
then you might have to borrow from a friend. I am no way suggesting you should go online and find one. You see what I'm saying?
I'm gonna do it.
10, I'll get you
Yeah.
one. I'll get you one, 10.
You guys
get me-
realize that this is
Wait,
on YouTube.
wait, Mr.
Anybody can see this.
All right, so I'm gonna
Yeah,
end
yeah.
the stream now before I get into more trouble.
Don't post this on YouTube. I'm not trying
Wait,
to.
is this
I'm not trying to have the
well,
feds
I
at my
will
door.
because this is a lesson. So
Turn on my
anyway,
No.
Oh.
Let's
I
not
will
do
see
that.
you
Keep
guys
it
on
low.
Wednesday,
No.
same
Okay.
time.
No.
You know the drill by now.
Yeah.
Mhm.
All right,
All right, so
Incriminating,
work
man.
hard, stay safe,
Yep.
don't go outside, okay? I'll see you
All right.
guys on
See
Wednesday.
you on Wednesday.
Done no,
Goodbye.
fam.
Keegan,
Done
come
no.
back into the Discord.
Haven't
Keegan,
been
come back
taught.
into
Yeah,
the Discord.
Keegan, join the
All right,
Discord
done no
server.
class.